UAV, aircraft, cruise, and hypersonic missile tracking systems use active radar illumination, thermal, and acoustic sensors. This creates critical infrastructure targets, which are difficult to procure, hide, and protect. Effective defense demands systems that merge large-scale coverage with small object tracking, seamlessly fusing data from distributed sensors. Conventional radar emits a radio wave, then detects reflections that are above the noise floor, objects with small cross-sections, or those using radar masking low observable technology barely whisper in reply. Active transmitters can be jammed and pose operational risks by revealing the position of essential assets. Even with large, high-power arrays, illumination fails to reliably detect drone-sized objects or those being shielded by plasma produced in hypersonic transit. To bypass these challenges, Whisper Hunter measures disturbances in ambient radio waves, FM, cell, other broadcast signals, and even celestial bodies to covertly track objects 50 decibels below the noise floor, finding signal where there is only static. Whisper Hunter learns how the radiation environment reacts to any moving object. It does not matter what the object is. Every movement results in a perturbation to the medium. Even though existing hardware is sensitive to these whispers, traditional signal processing is incapable of working below the inherent noise floor. Whisper Hunter is agnostic to frequency, signal structure, encryption, and protocol. It is an external add-on that allows existing hardware to detect objects large, small, slow, and fast, no matter what kind of signal they reflect. RocketStar and its collaborators have more than a decade of experience contributing data analysis and machine learning methods to our nation's defense and communications infrastructure. During this time, RocketStar curated a suite of digital signal processing methods, each existing due to a specific real-world problem our team had to solve. RocketStar sought to test its water-based thruster on NASA's Artemis 1 mission in November of 2022. But reliable communication with an array so small required identification and manipulation of signals well below the noise floor, leading to the development of what we now call signal boost. Combinations of these tools opened new application spaces, motivating RocketStar to assemble these DSP techniques into an all-in-one communications, reconnaissance, and defense signal processing solution known as Phoenix Eye. RocketStar's SyncWave is built into the core of Phoenix Eye to enable coherent fusing of distributed antennas into arrays regardless of their platform. Current methods of combining weak signals from separated antennas suffer from a dramatic power fall-off as carrier phase differences result in grating lobes, restricting antenna designs, and the maximum cost-effective size of receivers. SyncWave eliminates carrier phase differences across infinite inputs to provide coherent signal combinations without grating lobes. SignalPrint learns the fingerprint of any electronic transmitter, offering the ability to identify and track unique signals among indistinguishable hardware, measure component-level degradation, damage, and power modes, and provide situational awareness metrics such as device counts or command authentication. Phoenix Eye is designed with cybersecurity in mind, leveraging SignalPrint to circumvent traditional disruption and replication using hardware-level flaws and tolerances as friend or foe identification. Even two PCBs with the exact same design from the exact same manufacturing line will have imperceptible differences that Phoenix Eye can recognize to enable hardware-level targeting. Omni-PNT is an alternative position, navigation, and timing software system that uses radio waves emitted from celestial objects like the sun, moon, planets, satellites, and pulsars. In Phoenix Eye, Whisper Hunter can leverage Omni-PNT to detect small and hypersonic objects with ambient radiation produced by celestial sources. This also means detection and tracking receiver stations are capable of concurrently serving as unjammable geospatial positioning references to within 100-meter accuracy. Whisper Hunter requires minimal data bandwidth to communicate between sensor nodes in an array, making it easily scalable using SyncWave to interconnect existing detection systems that span coverage, target size, and speed domains. RocketStar's suite of digital signal processing methods have proven success supporting the U.S. Air Force, Missile Defense Agency, U.S. Army Special Forces, U.S. Coast Guard, and multiple commercial sector satellite communications and global navigation satellite system providers. Phoenix Eye field tests used a 5-receiver array and single ambient transmission source to detect military drones and vehicles while distinguishing them from several low and high-flying birds. Currently at a technology readiness level of 6, components of Phoenix Eye have successful mission heritage, while prototypes of the combined system have been used to detect small, low-flying objects during field tests. Investing in entirely new platforms for detection of small and hypersonic threats may entail much longer development timelines that could be outpaced once again by the modern battlefield. Phoenix Eye provides an immediate, scalable solution to an ever-growing technological gap. Due to its low power and compute requirements, Phoenix Eye can operate on board and on demand without having to be integrated directly onto proprietary compute platforms, and instead be provided as a small independent compute card compatible with already deployed assets. Because Phoenix Eye seamlessly integrates into our existing missile defense infrastructure, it will address vulnerabilities in our detection of elusive air and space domain objects at key locations today, and later provide national-scale coverage and coordination through the Golden Dome, America's next-generation missile defense shield. SyncWave will ensure taxpayer dollars are better spent on networks of interconnected arrays instead of large, difficult-to-maintain, and exponentially more expensive heritage receivers. Without SyncWave, individual assets and layers of the Golden Dome must separately analyze data about a target and exchange interpretations, increasing response times. Instead, Phoenix Eye coherently synchronizes data across domains to achieve continuous monitoring, enabling custody layers across dissimilar assets and providing a continuous stream of live consensus. Signal Boost and OmniPNT enable complex arrays of small sats to reliably communicate their position and other critical sensor data, while Signal Print will ensure no adversary technology is capable of disrupting or sabotaging that network. Whisper Hunter provides Golden Dome unjammable tracking of small and hypersonic threats, round-the-clock situational awareness, without creating a point of failure in high-power transmitters that reveal their own position. Phoenix Eye can be integrated into the lifecycle of defense and reconnaissance data to ensure relevance whenever it is called to action, as opposed to static implementations, which age on the shelves only to become irrelevant on the battlefield. New AI compute infrastructure such as Stargate provide the technology necessary to interpret battlefield data. Phoenix Eye is the algorithm needed to turn these new resources into operational advantages. Phoenix Eye is a software that overcomes hardware limits, inefficiencies inherent in traditional RF signal processing techniques. Support Phoenix Eye because America's next-generation missile defense shield requires next-generation software.